Here we have an exercise that has to do with radicals. And before we start with this problem, we need to understand a couple of things about radicals. So how to identify radicals? Radicals, you can identify them when you have the radical symbol, we call the radical symbol. Also, it contains, which is called the radicand, which is the number that is inside the radical symbol. And lastly, it contains, which is called the index. Index is, it tells you how many times you have to multiply a number by itself, so it gives you the radicand. So this concept is basically, we're looking for a number b, so that we take the number b and we multiply the number b by itself n times, and it will give you the number 8. So that's basically the concept. By default, when you see radical alone and you don't see the index right here, that means that the index is the number 2. But in mathematics, we don't write the index 2, we consider the square root of a number. So based on this, for an example, to understand this example, we're going to go to the basic example of the square root of the number 4. So what does this mean? In this case, the radicand is 4 and the index is 2. Remember, when you don't have the index on top of the radical left in the upper corner, that means that the index is the number 2. So we need to look for a number b. And this number b, what it means is, since the index is 2, you got to multiply b time itself twice. It means 2 times, not divided by 2. This means multiply by itself 2 times. Somehow that it gives you the number 4. In this case, this number is 2 times 2 equal to the number 4. So as a consequence, the square root of number 4, which is that number b, it's equal to the number 2. Keep in mind again, this right here means that you're multiplying b by itself twice. It doesn't mean that you're dividing b times b by 2. Okay, so another example. Let's go now to, let's complicate it a little bit more. Now we're going to have the cubic root of the number 8. My radicand is still 8. My index is the number 3. What this means is that I need to look for a number b. That when you take b and you multiply b by itself 3 times, let me put now 3 times here, it gives you the number a, which is in this case the number 8. Okay, so what you do now is you look for that number, and that number is equal to the number 2. So 2 times 2 times 2 just makes it to 3 times. It's equal to the number 8. So the answer of the cubic root of the number 8, it's equal to the number 2. Okay, so that basically explains the basics of radicals and the principles. So now what we're gonna do is we're gonna go ahead and explain what's the relation between a power and a radical, and we're gonna use it in later exercises. So the radical and the power, they're inverse operations, and inverse operations in mathematics, what they do is they simplify each other. What does that mean? That means that when you have basically a radical, let's say radical n of the number 8, and you take that number, for example, or that radical, and you elevate it to the n power, the power and the radical inverse operations, since basically the power is n and the radical is n, just to simplify each other, and as a result you extract the number a. As long as it's simplifiable, sometimes they're not. Okay, another way of looking at this exercise is when you have the radical n of the number 8 elevated to the n power. Okay, you can rewrite this expression by saying this is the radical n, the number a elevated to the n power inside the radical, and as a consequence you can also simplify here, and that gives you the radicand a. Okay, so let's take a look at a couple of examples. For example, if you have the square root of the number 2 elevated to the second power, you look at the relation between this and this. So the index is 2, the power is 2, they do simplify each other, and as a consequence this is equal to the number 2. Okay. Another example, if you have radical 3 of 2 to the third power, you can simplify this 2, and then this is equal to the number 2. There are other ways to simplify radicals, and that you're going to see in other exercises. Now, the idea is basically to solve for this. Okay, so in this case, you have the square root of 3 that multiplies together the square root of 3 plus 6 times the square root of 3. So here, what you can do is you can actually distribute. So you will multiply the square root of 3 times the square root of 3. And then you multiply the square root of 3 times 6 times the square root of 3. So it's 6 times the square root of 3 times the square root of 3. Remember that when you multiply, it doesn't matter in which order, basically, you place them. Now we're going to solve for this and for this at the same time, and then at the end we're going to deal with the addition. So a square root of 3 times the square root of 3 is basically a number times itself. So going back, if you have the letter x and you multiply by itself, it gives you 2x to the second power. So we're going to apply basically the same concept here. But the difference is instead of using x, we're going to use the square root of 3. So a number times itself is equal to the number, which is the square root of 3, elevated to the second power. Same concept over here. So this is plus a square root of 3 to the second power. Based on the property that I explained before, you have index 2 for the radical, you have power 2, and they're inverse to each other, so they simplify each other. And you're left only with the number 3 from here. You apply the same property over here. You have the square root of 3 elevated to the second power, the inverse operations, radical, index 2, power 2, you simplify, and then you extract the radicand, I'm sorry, but don't forget that you have basically now 6 times whatever was left in here, and after you simplify, the 3 is left, so you have 6 times 3. Now you keep applying the order of operations, so you solve this first, which is equal to 18. So you have a 3 plus 18, and then you solve finally all this, which is equal to 3 plus 18 equal to 21. So your answer for this particular problem is equal to 21.